Hello everyone, welcome back to the channel. So in this video, the topic is about a CPU scheduling algorithm, that is SJF, or in other words we can say shortest job first. So in the later part of the video, we will also see the program which implements this concept. A brief introduction on SJF, that is a CPU scheduling. The shortest job first or shortest job next is a scheduling policy that selects the waiting process with the smallest execution time to execute next. SJN, also known as shortest job next, can be preemptive or non-preemptive. So it means that out of all the available processes that are in the waiting state, this algorithm will select a process having a minimum burst time which to be executed next. This SJF by default is a non-preemptive concept. By non-preemptive, I mean once the CPU has allocated a process, it cannot be forcefully removed from it until and unless it completes its execution or it is terminated. So that is non-preemptive. Coming to the algorithm, sort all the processes according to the arrival time, then select that process that has minimum arrival time and minimum burst time. After the completion of the process, make a pool of processes that arrives afterward till the completion of the previous process and select that process among the pool which is having minimum burst time. Now, how do we compute times in the given program? So this SJF scheduling algorithm includes some of the terms like completion time, turnaround time, waiting time, which plays a vital role in solving the numerical based on SJF. So completion time means the time at which process completes its execution. Turnaround time is a difference between the completion time and the arrival time. And at last, the waiting time, it is the difference between the turnaround time and the burst time. If you look into the picture here, there are four processes with their respective burst times. So as I said before, the process having minimum burst time will be selected first. So here P4 is having the minimum burst time and it will be executed first with the waiting time 0. And after P4, P1 is allocated, and after P1 it is P3, and at last it is P2. So this is how scheduling of the processes takes place. Here in the example, I have considered 5 processes P1, P2, P3, P4 and P5, and their respective arrival time and burst time is given. Now we are supposed to find turnaround time and waiting time of the processes using this SJF algorithm concept. So in order to solve this numerical, we have to write a Gantt chart. So this Gantt chart basically represents the allocation of processes into the CPU. If we look at this chart here, at 0 CPU time, there is an allocation of processor 4 because the arrival time of P4 processor matches with the CPU time. So that is why P4 is allocated and its corresponding burst time is 6. So this particular unit states that the arrival time of P4 is 0 and the completion time or the burst time of P4 is 6. So for the next processes to be allocated, we have to check the arrival time for 6 units. We have to check the arrival time for 6 units. So here P1, P2, P3 and P5 all are having the arrival time within the 6 units of time. So they are all in the ready queue. So if this is the case, Then we have to look out for the burst time. So P1 and P3 is having the minimum burst time among all the four. But then again, there is a collision occurring here because both the processor P1 and P3 is having the same burst time. So in this case, we have to apply the concept FCFS, that is first come first serve. So since P1 is appearing first, P1 is allocated here. Then after that, the burst time is 1. So the completion time will be 6 plus 1, that is 7 units of time. So at or within the 7 units of time, P1 process gets executed and it is terminated. How the processing, this is how the scheduling of the processes into the CPU takes place. Now for the turnaround time and waiting time, as I said, the formula for turnaround time is the completion time minus the arrival time. And for waiting time, the formula is turnaround time minus burst time. So once you get the column of completion time, it is easier to find the other two. Now let us look into the program. Here in the program is expecting from the user the number of processes to be inputted and the enter the burst time also for the respective processes. Sorting of the process takes place in this program code, and after that the waiting times and turnaround time is calculated in this part of the program. Output will look as here, like this. Enter the number of processes. I have entered 3 processes and their respective burst times are 5, 3 and 8. So in the table here, see P1, P2 and P3 are sorted according to their burst times, right? So first 3 is the minimum burst time, so P2 will be allocated first, and then comes P1 and then P3. Again waiting time is calculated and turnaround time is also calculated. So this was about the program. And coming back to the theory concept for SJF, there are some advantages and disadvantages. The benefits is that it is better than first come first serve algorithm because it reduces the average waiting time. SJF is generally used for long-term scheduling. It is suitable for the jobs running in batches where runtimes are already known. SJF is probably optimal in terms of average turnaround time. Then the limitations of SJF is that SJF may cause very long turnaround times of starvation. In SJF job, completion time must be known earlier, but sometimes it is hard to predict. Sometimes it is complicated to predict the length of the upcoming CPU request, and at last, it leads to the starvation that does not reduce average turnaround time. So this was about the concept of CPU scheduling algorithm of SJF. Thank you. Thank you for watching.